Good morning. Good morning. Good morning. Been thinking about simple computing, big surprise there, and little bits of cryptography. I'm just trying to. I've had this idea for a long time. It's like a key separation service, so that people were given access to keys and could request them, but the key was required for translating data on other services. So you would basically have keys on two different servers and then the content on one server. So you could post things to Facebook, for example, that's encrypted in like a base 64, something not human readable but parsable, able to I guess it doesn't actually matter. No, you got to be able to copy paste it pretty easily, so standard ASCII character set will fit in there. But you publish something like that, and then it is generated as or when it comes up in your browser reads, detects the encrypted data, sends a request to the key server, sees if you have access for that key. If you do, it returns the key, and you receive the key, and then it decrypts it transparently, I guess. You would see it decrypted, and you can do all kinds of cool stuff with that with the browser updating, because the browser has, like, you could put a base 64 image in there as text and it'll render it. So to the end user who has access to the keys, all of that would be pretty much seamless, which is pretty neat. The point is just kind of to break up the content so that it's in different places, and then so the problem is not one-to-one communications. That problem has been solved pretty handily by a variety of options. The problem is one-to-many, and what's odd about the one-to-many is you usually don't have full knowledge or full trust of the many that you're sending it to, but you still want it to be not immediately viewable. It needs to be something that's something you actually have to penetrate into in order to discover the information that you need. Somewhat difficult to get to it, or it's shared at a certain point, and then from then on it's only shared by people who want to spread that access to people they trust. There's a whole bunch of other trust tiers and trust trees that can be built from things like that, so that if you have data that you're sending out to 1,000 people, and one of those persons says, one of those persons is a fool and thinks that another person is trustworthy, and they're not, and they share that key with that person, then you're now basically sending information out to 1,001 people, and one of those people is not trustworthy. And the idea would be to set it up so that your data comes out in such a manner that it is targeted to 1,000. It can be spread across 1,000 people, but it also keeps track of who receives what and where that information came from, what the key pairing for it is, so that if that information gets further out, that it can be tracked back to one person, and that one person who was untrustworthy in the original 1,000 can be removed from whatever the list is. I'm sure this is something that's already been done, but complicated encryption schemes are, you can't swing a dead cat without hitting one. I'm not sure why it would be a dead cat. I guess you wouldn't swing a live cat. You probably shouldn't swing cats at all, actually. That's an odd saying. It's an odd idiom. Okay. That just derailed the train of thought there. There's no shortage of complex cryptography schemes, and there's no shortage of there's no shortage of cryptography schemes that are too complex for lay users to use. Lay user is a word I've never used before. I guess I've just invented that, possibly. Layman and user. Although Linux users are usually called losers or L-users. So I don't know which is better. It's not very accessible. Further, if the scheme is complicated enough, people failing to understand it, or people failing to understand it means that they will use it improperly, which is actually a worse outcome, because what you have then is people who think one person might be subverting the encryption of the rest of the people who are actually doing it right. So simplifying things or making things mostly automatic is to be desired. I still maintain, and I'm still working on, say, like AES 128. I think that's just fine. I really do. I think the amount of computing power that you need to bust AES 128 is sufficient to make it sufficiently secure, especially if you have like PFS key modification that changes going forward. Although if you combine that you would have to combine that with other keys so that things actually rotate. You have to think about that. You know, dedicating CPU power to breaking one message should not crack wide the entire conversation. Things should update and change as they go on. But for that kind of thing, I still prefer the one-time pad, which still, I've got scribblings going back for years for one-time pad, simple basic encryption schemes. And it's mainly just about key management, which is something that can be handled in software pretty handily, pretty transparently. And as long as people handle their keys properly, you can have some idea that what's getting there is not being shared and not recoverable afterwards. And there are actually user experience things that you can do to transparently make it more difficult to screw up your key management. What I find particularly interesting is combination keys. If you take bits of data, XOR is always reversible if you have the inputs. So if you have multiple inputs and you XOR them together, then you get the same output. You get one output. And if you take that output and XOR it with all of the inputs except for one, you get that one input. You can reverse it. And that gives you options for key management and key transmission, which is also interesting. I believe there's sufficient data on the internet to be able to process it to a point of sufficient sufficient entropy, actually, is the right word. So, functionally, I don't know if you've been following along with this. I'm barely following along with it. For that one-time pad key management, you would have, normally what happens is you take a randomized key and another. You take a randomized key and you exchange it with someone. So Alice has originated a randomized key. Alice created a randomized key and then made 2 copies of that key. And then Alice shares securely that key with Bob. Then Alice takes her message and XORs it, essentially, or I guess technically like a mod. Modulus is it with the message length of that key. So if the key is 1,000 characters and the message is 20 characters, then Alice basically burns 20 characters of that key, and it's now 980 characters left in the key. And then takes that key and takes the encrypted information and sends it to Bob over unencrypted channels, over public channels. Bob then receives that information, does the same XOR with the first 20 characters of the key, and gets back the message. The key exchange is what is particularly interesting, because setting up software to manage keys for who has access, who has what keys, is actually pretty interesting, because you can set up, you get that many one-to-many data transmission if you can exchange those keys securely or semi-securely. Because again, this is anytime you're talking with people who you don't 100% trust, you're talking with people who there's I had talked about PGP before, and like PGP allows encrypted communication between strangers, and that's really cool, except you shouldn't expect your communication with strangers to need to be encrypted. Like, you don't trust strangers. That's kind of the point. That's why they're strangers. So making it so that I can talk super securely with a person I don't know or trust is like it's like an oxymoron. So you can understand that there is, like implicitly you're speaking to people you don't know or really trust completely. You might trust them 50%, you might trust them 75%. It might not even be that important, the information that you're sharing. You just might want it to be encrypted, and that's totally fine. In that case, simply sending people, a gigabyte of keys, serving a key file somewhere for a week, and everyone has the opportunity to download it. And then once everyone that's on your mailing list receives that key, you remove the key from public access, and then begin communication using that key. And then, ideally on a browser side, which again, we don't trust browsers, but on a browser side, you can have what's called a bookmarklet, which is essentially a browser extension, except before there were browser extensions. So a bookmarklet simply applies Java to the page, JavaScript to the contents of the page. So you could take that bookmarklet and kick it off on the page, and this is actually very bad browser security, and it's something that browsers have blocked, because it is essentially cross-site scripting, because you're taking the information that's on one page and you're gathering information from another page and combining it and representing it on that same page. Because if I go to my Facebook feed and I see gobbledygook of base 64 characters from the guy that sends that information, I press my bookmarklet and it scans the web page, it finds that block of data, it takes the key that's stored either locally or, in the case we were talking earlier, on that key server, combines the information, swaps out that gobbledygook with the translated message, and hey presto, the Facebook feed has no idea what your message is, because it was just changed on the client side. And you've got basically a transparent experience where you're seeing that key being displayed, or that content being displayed unencrypted through your friendly common channel that you really like, which is Facebook in this case for some reason. But that can be Twitter, that can be anything else really. It actually can be Twitter, because Twitter has a character limit. So Twitter's character limit would allow it to that's interesting. The point is to just kind of make it transparent, and that's something that is accomplishable with what we currently have. The problem is browsers have their security cranked up so that that's a kind of thing that doesn't happen because it's insecure. And the alternative to that is you make an extension, a browser extension, and that browser extension is something that is, surprise, it's going to be something that you have to submit code for, and they can, open up the code and look at it, and review it, and figure out what it's doing or not doing. Although technically, yeah, I would rather people not even know that it exists. A bookmarklet can exist on your browser, your local browser, wherever it is, but an extension has to be shared and all that. Actually, there's probably a way around it at this point. I remember Chromium, like while I was working on this, while I was developing bookmarklets, Chromium came out with an update that blocked bookmarklets, like specifically. I was like, huh, that's weird. But now Chrome is, no one uses Chrome. There's still Electron apps though, so maybe like a Brave browser extension would be something that might make sense. Interesting. This is the whole one-to-many thing, like the encrypted chat program, where everyone attends a chat room, and that chat room, everyone who sends information to that chat room, everyone in that chat room receives every message, and it's all encrypted. However, on your client side, the only messages that are displayed are those which are unencrypted. So those which can be unencrypted. So if you have a key for it, it'll decrypt it, and then you'll get a validation, or not a parity bit, like a hash check, so that you know that the message has been decrypted, and then the browser will display that message. So essentially, your message is going out to potentially, hundreds, maybe thousands of people, and then the only people actually seeing it are those who have the source key. That's also interesting. That was an AES 128 thing, because that's nice and quick. And then the question will be, who's actually viewing the message when the message is going to everyone. It's kind of an obfuscation thing, but whatever.